Hey everybody, this is Mr. Schultz here with you, and we're going to be taking a look at section 9.1.5, How Can I Find Missing Parts? Applications of the Pythagorean Theorem. In this section, you have studied different properties of triangles. You have used Pythagorean Theorem to describe the special relationship between the sides of a right triangle. In this lesson, you will use these ideas to solve a variety of different problems. So let's take a look at our first one. All right, so 9-72 says this. Anne is measuring some fabric pieces for a quilt. Use the Pythagorean theorem and your calculator to help you find each of the missing side lengths. Decide whether each answer is rational or irrational. If it is rational, explain whether the decimal repeats or terminates. So here we go. Let's take a look at part A. So we're just going to solve this using Pythagorean theorem, which a reminder of that, a squared plus b squared is equal to c squared, where c is always the hypotenuse or the longest length opposite of the right angle. And A and B are just either one of the legs. Doesn't matter if I put 24 in for A or 24 in for B. It can be either one of those legs. Same thing with 32. Doesn't matter if I put it in for A or B. So then let's go ahead and solve this. So I just end up putting the 32 and the 24 in for my legs. So 32 plus 24 squared should be equal to c squared, or x, the length that I'm looking for, x squared. So let's start to use our calculator to help us solve this here. So I'm just going to start to put this in my calculator. So I've got 32 to the second power squared plus 24 to the second power, and I get that number there of 1,600 or 1,600. So my last step then is that now that I know that all of this stuff here up top is equal to 1,600, that's x squared, I need to undo that squared. So I undo it by taking the square root. So I'm going to take this square root key right there, and I'll just use my previous answer, or 1,600, and find out that this should be the number 40. All right, so that should be the number 40. So x should be equal to 40 here. Now we know this is a rational number because I can write it as a fraction. The fraction would be 40 over 1. That is equal to the number 40. It's also a terminating decimal, meaning that it ends. It ends right there. It ends at 40.0. It ends right at the decimal point. So now let's take a look at the next two problems, and be careful with these two because now you've been given the hypotenuse, so you need to find the legs. So before we were adding up the legs, we might have to do a little bit of subtraction here to find out what each of these legs are. Take a second, pause the video, and we'll go through the answers here in just a second. All right, so in this one, I'm going to plug in the things that I know into my a squared plus b squared is equal to c squared. I know that one of my legs is 10. I don't know what that second leg is, so I'm just going to call that x. My third leg my hypotenuse should be equal to 20. So to solve for this, I need to do some subtraction now. So I just need to take off this 10 squared, which is really just the number 100. So I'm just removing 100 from each side, and that'll give me back that same x squared is equal to a number. So when I do 20 squared minus 10 squared, I should get the number 300 here. And then I just need to take the square root of 300, and I get this number here, which is 17.32, and it just keeps going on and on and on. I don't see any sort of a pattern here, so when I slide down and look at this number a little bit more closely, I don't see any sort of a pattern. Nothing is repeating. Maybe 808, this 080 is starting to repeat, but I'm going to guess based off this front part that it's not. And so this is what's going to be called an irrational number. This one's going to be an irrational because there's no way for me to write that as a fraction. It is a not terminating or repeating decimal. It just keeps going on and on and on. Let's take a look at the next one here. Part C, and we're going to do the same thing again. But now I'm just going to do it with decimals. So I've got a squared plus b squared is equal to c squared, and I've got my c, that's 9.5. I've got my a, or if you want to call it b, it doesn't matter to me. But I'm going to be looking for at least one of those legs. So that's going to be x squared. So now I just need to plug this into my calculator and go from there. So again, I'm going to do a little bit of solving here. I'm going to take off this 7.6 squared. Whoops, I've got the squared on the 9.5 there. And so then when I do that and I plug that all into my calculator, so 9.5 squared minus 7.6 squared, I get 32.49. So x squared is going to be equal to 32.49. So I just need to take the square root of that. Square root of 32.49, that's equal to the terminating decimal, 5.7. So this leg here is going to be 5.7 centimeters. So 5.7 is a terminating decimal. Therefore, I know this is a rational number because it's terminating. I could write this as a fraction. I could write it as 5 7/10. So something like that. I could call it 57/10. Something like that. Those are all fractions that makes this a rational number. Let's take a look at the next problem here. And actually, before we move on, I wanted to show you this here too. I can also tell that this is a fraction, because if you look in Desmos here, you can see that it's actually got these fraction keys here. You can turn these things right into fractions right there. So just like I said, 57/10, you can turn it into that fraction, which is how you know that it's a repeating decimal as well. Let's take a look at the next one now. Okay, so 9-73, starting to get into some word problems. So whenever I do word problems, I usually have a two-step approach. I just read it the first time. The second time, I go through and I look for my key information. And I want to be sure and underline that stuff. So first, I'm just going to read it and try to understand it. So Coach Kelly's third period PE class is playing baseball. The distance between each base on the diamond is 90 feet. Lisa at third base throws the ball to Dano at first base. How far did she throw the ball? State whether your answer is rational or irrational. So basically, is it a terminating, repeating, or neither decimal? So we got the problem. We're trying to figure out how far is the throw from first to third base. Okay, so let's find out. Let's get some key information here. So key information that I've got here. 90 feet, that's a good number there. We've got this third period thing here, and that's another number, so I like to just underline all of the numbers. And then it says that Lisa at third base throws to Dano at first base. So how far did she throw the ball? So the information that they've given us is this. On the baseball diamond, between each base, it is 90 feet. So I've got 90 feet between each of these bases here. But what I'm trying to figure out is that Lisa at third base threw the ball to Dano at first base. And we're trying to figure out how far is this throw, this green line throw here. Well, what I've really got here is I've got a triangle. Look at this. Right there. It's a right angle triangle. So if I have it set up like this, if I just kind of change the orientation, well, I've got my second base is right there, and this would be my green line, the distance from third base to first base. And I've got what each of these legs are, 90 and 90. So I just need to do Pythagorean Theorem and find out. So 90 squared plus 90 squared should be equal to my green line, or that distance, squared. Let's find out how far that is here by plugging this into our calculator. All right, so we end up with 90 squared plus 90 squared equals 16,200. So I'll take the square root of that, and I end up with this number here, which is 127.2792206. I don't see any sort of a pattern here, so I'm just looking at this is going to be about 127 roughly feet. And but I don't see any sort of but going to our second part of the question here of if it is rational or irrational. Well, this one here is going to be irrational, which I started writing an R for irrational. That's wrong. It is an irrational number because I don't see any sort of a decimal that terminates or ends, and I don't see any sort of a repeating thing happening here either. So it has to be irrational because it's not terminating and it's not repeating. Not and not. Let's take a look at the next problem. Okay, 9-74 here says this. As a city planner of Wright City, you are responsible to report information to help the Board of Supervisors make decisions about the budgets for fire and the police department. The board has asked you to report the answers with the following questions. Each grid unit in the figure represents 1 mile. For fire safety, the bushes will be cleared along the perimeter of the city. What is the length of the perimeter? Include all of your calculations in your report. So here is Wright City, and I'm trying to figure out what is the perimeter of this triangle. Okay, well, perimeter is just adding up these side lengths here. So I'm just going to go and I'm just going to count because each square is a mile. So I've got 1, 2, 3, 4, 5, 6. So I've got one side. But then I've got this one. That's not quite one. I'm not really sure how long that next length is going to be here that I've got highlighted in green on the lower left. So how might I be able to do this? Well, finding a length, I can just turn this into a triangle here. Say, look at this. I've now got this leg of 3, and I've got another leg here of 1, 2, 3, 4. So I've got a leg of 3 and a leg of 4, so I can just square both those and take the square root, and that'll give me my green length here. So I'm just going to say 4 squared plus 3 squared should be equal to that green, which I'll just call the green squared. Well, 4 squared is 16, 3 squared is 9. That should be a grand total of 25. So I just need to take the square root of 25. That's that nice and round number, 5. So now I've got one more side length. And I just need to find my last side length, which will be this top one. Do the exact same approach. Just look for those side lengths here. So I've got a leg of 2, and I've still got the leg of 3. Let's see what that looks like. So I've just got the side lengths of 2 and 3. So that's going to be 3 squared, which is 9. 2 squared, which is 4. 9 plus 4 is 13. So the square root of 13 is what I'm looking for this purple side. And that's the decimal 3.6. We'll call it 3.61. It's this decimal that just keeps going on and on and on. So we're going to call the purple length 3.61. So now here it says, what is the length of the perimeter? So here, I just need to add up all these sides. 6, 5, and 3.61. So 6 plus 5 is 11. So I'm just going to add 3.61 onto that. So when I do that, I'm going to have 5 plus 6. That's 11, like I just said. And I'm going to add that 3.61. So I should be up to about 14.61. And I'm going to put that little squiggly line there because it's roughly that. And remember that this was in miles. So 14.61 miles. Let's take a look at the next problem. Okay, so back to another word problem with no diagram. So let's be sure that we just read it the first time. And then the second time, we're just going to look and underline that key information. So here we go. So Scott and Mark are rock climbing. Scott is at the top of a 75-foot cliff when he throws a 96-foot rope down to Mark, who is on the ground. If the rope is stretched tightly from Mark's feet to Scott's feet, how far from the base of the cliff, directly below Scott, is Mark standing? Draw a diagram and label it, then find the missing length. Is the length irrational? Okay, so let's grab our key information here. So they're rock climbing. Scott is at the top of a 75-foot cliff. He throws down a 96-foot rope down to Mark, who is on the ground. If the rope is stretched tightly from Mark's feet to Scott's feet, how far from the base of the cliff, which is directly below Scott, is Mark standing? We want to draw a diagram and label it, and then find the missing length, and then decide if the length is irrational. So let's see what this looks like. Okay, so this problem is worded a little bit weird, but the stuff that we know. So Scott's at the top of a 75-foot cliff here. So Scott's going to be at the top of this cliff that's going straight down. And he throws down a 96-foot rope to Mark, who is on the ground. It doesn't really tell us where Mark is standing, but based off what they're saying of how far is from the base of the cliff to Mark, I'm assuming that Mark is not standing directly below, because that would just be 75 feet, and that's not much of a question. So what I'm assuming is that Scott threw this rope at an angle like this, and he's saying that it's 96 feet this way. And so what they're looking for is what is the base from the base of the cliff to where Mark is standing. So you're looking for what is this here if Mark is standing right there. So a little bit of a weirdly worded question there that we had to make a little bit of assumptions on, but this is just going to end up being another Pythagorean theorem thing, but this time we want to solve for the legs. So why don't you pause the video, set up and solve for that, and I'll show you what I got here. All right, so here's what I came up with here. So I'm taking the hypotenuse and I'm subtracting the leg to get 3,591, which is what I did in my calculator here. And then I just need to take the square root of that to find out what this other leg is, the distance from the bottom of the cliff to Mark. So that ends up being about 59.92, or if it's rounded, so 59.92 feet. So let's look at these other questions here that they're asking us. So we drew the diagram. We answered that he is 59.92 feet away, and we found that missing length. The last thing we need to do is the length irrational? In this case, yes, it is. It is irrational. Because if I look at this number here, 92495307, I could just be stating random numbers there. So remember, if it is irrational, it does not terminate or end, and it does not repeat. Well, I don't see either of those things happening there, so it looks like it is just going to keep going on and on and on. So let's take a look at the very last thing the math notes here. So squaring and square roots. So basically just kind of showing why we call it a square root here. So squaring just is referring to the shape of the square. 6 times 6 means squaring. You're just basically creating a square. And then you do the square root, you're saying what is the root or what's one side of this square? So I'm just trying to undo the multiplication that happened here on the first side. So that's what that square root or the radical sign. Eventually, you can actually get these things to be like the cube root, which would be the third root, or the fourth root, or the fifth root. Other things there, but we're mainly just going to hang out in this square where it's just two of them right now. And so it's all based off this shape of a square right there. And that's everything that I've got for you today. Have yourself a good rest of your day.